Hello, and thank you for watching. I'm going to show you a small example of flyweight pattern, and I'll be starting out with a small program that does not utilize the flyweight pattern, and we'll change it to use the flyweight pattern. So, to get on with the program, we have a tree here. It has a name, a color, and possibly some other tree data, and has a location. And we want to paint a fairly large number of trees on a J-frame. We have some getters and setters here, not so important now, they will be later. We have a constructor, and we have a way of drawing this tree on a graphics. So we'll be using the location to locate the tree and the color to fill the tree. Okay, and to create trees, we have a forest, which is the J-frame we're going to paint the trees on. It has a list of trees, and we can plant a tree simply by creating a new tree and adding to the list, right? And whenever the J-frame needs to repaint itself, we will loop through all the trees and call tree.draw. Remember, we had a draw method that only took graphics as a parameter because the tree itself had all other necessary variables. Okay, and to create a forest and plant trees in it, we have a main method, create a new forest, and we loop for 10,000 times. This could easily be more. And we plant trees. Now, what we do when we plant trees is that we create random locations. This is here, random locations. But for each loop, it's always the same color, as this is the point in the flyweight pattern. We create huge numbers of trees that all have the same color. And these other data are also the same, right? So we basically create two different types of trees, the summer oak and the autumn oak, which is orange, like. And yes, that's it. Let's see how this runs. Hopefully, moving right along. Okay, so we get lots of trees. Okay, but a lot of aspects of the trees are the same. That's the point. We're going to reduce the memory load of the tree. So let's look at the tree first. We have these three variables. They'll always be the same, or rather, one out of two. It'll be one of two possible combinations, and that's what is the indication to use the flyweight pattern. Whereas this one it changes all the time. We have huge number of different locations in the program, but only two possible values of these three variables. So what we're going to do is remove the location from this class. Okay, so I copied the three classes to another package here. So we have the tree here again. And as I said, we're going to remove the location. And we're going to move it to another class I created here that's called tree with location. So let's get rid of it. Okay. That was easy. So we need to remove these also, right? And we're going to take it away from here. There, gone there too. And now the important method, the draw method. Now it needs the location. So what we do in the flyweight pattern is that every piece of information we take out of the class, we need to pass as a parameter in the methods that need it. Okay. So we take out the piece of data that is varying all the time, and we pass it as parameter to the methods needing it instead. Okay, so what do we do with the location? We move it to this class. So let's fill this one up instead. It'll have the location and a tree. And we can create a constructor using both of these. That didn't work out too well. There you go. And we'll create a draw method here. That'll only take a graphics. Remember, that was the same. That didn't work out too well either. There you go. Okay, remember now this actually has the same signature as the draw method that the tree used to have. So what is going to happen here? We're going to say tree.draw using the graphics supplied in the parameter and the location that we have ourselves. Okay, great. This works out fine. Now let's see what should happen in the forest. We still have the plant view method. Oh, this didn't work out too well. This will happen sometimes when you copy code. Okay, now we get the error here. See, not supposed to. He's not supposed to construct a tree. We're supposed to construct a tree with location. Okay, so this doesn't work either. This is wrong. So we create a tree with a location. So far, nothing really has changed, except that we split the class tree into two. So when we made a tree with a location, we supply the location and the tree. And this probably also needs to change. There you go. And here also. So this works out fine. Let's see, from the forest point of view, it only supplies the graphics. But from the tree with the location, we get the graphics, but we supply the graphics and the location to the tree because the tree no longer holds the location. So this works out, I'm sure this will run, but we have a small problem. We still create many of these, a new one each time. Okay, let's see what happens in the start method. New colors all the time. Okay, so let's see. What we should do here. We need to make sure that we don't create trees all the time. So we do that by introducing a tree factory. So what we're going to do here is we're going to create a map that holds all the created trees, indexed. And we're going to make this static and private. Create a his map. There you go. And each time we need a new tree, we're going to look it up in the tree factory to see if it exists, and if it exists, we're going to retrieve the existing tree based on the name of the tree. And if it doesn't exist, we're going to create it, add it to the hash map, and return the tree. So we're going to make a public method that returns a tree, call it getTree or getInstance, possibly. We're going to supply the name, and we're going to look it up in the trees list. Get, it must be. There you go. Now, if it exists, it'll be in the result. If it doesn't exist, we have to create it. So we're going to create a new tree with we need the other parameters as well. Parameters from the tree, the constructor of the tree. Let's grab those also. There you go. New tree, name, color, and other tree data. Okay. I'm going to add that using the name as a key and return the result. There you go. So we're going to use this one when creating the tree here. Instead of writing a new tree, we're going to write tree factory dot get tree. I didn't make it static. What a shame. Get tree. There you go. Okay. So We create lots of trees with the location, but to the degree possible, we're going to reuse the trees themselves. So we should only be creating 2 trees here. This might not seem like a lot, but the list is quite long, so it should have it'll have a good effect on the memory implant. Yes. Okay, so let's see if it runs first. Probably doesn't, but see if there's some build errors. So it works. Great. So let's see what we did. We created, we we pulled out the location from the tree and put somewhere else. It could have been, now I put it in this tree location, but in a similar situation, it could have been maybe just in the forest maintaining it, or even here. This one knows the X and Y. So depends on the situation. It's not where it ends up that's important. It's important that it's moved out of the tree. To make the tree still work, we need to supply the location in all the methods that used to use it. So that means that the surroundings need to supply it. That's what the tree with the location does here. And finally, we need the tree factory to make sure that we don't just keep on creating trees. So it's a very, very simple situation. Now, if this is running in a multi-threaded environment, we need to make this protected somehow. Otherwise, you could have the situation where one thread reaches this, asks if the result is null. It might be null. It'll go down here. And then the other thread comes in, asks if the result is null. If it's null, it goes down here. And they could both add the same to the list. I think the list will probably blow up. So you need to do some sort of synchronization here. And there's another thing that you need to consider, and that is the new guy in town, the new programmer who doesn't know that this is actually a flyweight object. He just starts changing the name. He calls this setter with a new name, or he changes the color, or something else. And it's not going to work out very well. So we need to make sure that this object is immutable. We can leave the getters, but definitely need to remove the setters. And if the getters return objects that are not immutable, like the string is immutable, it won't be changed from the outside. So you can return it safely. I'm not sure whether the color is immutable, but I think as a rule of thumb, you need to just get rid of all these. You got to be very careful about it, at least. You got to make sure that they're immutable. So I think that was the final point. uh, less memory imprint, uh, slightly more complicated program, but that's the point of the flyweight, to make sure that you don't create too many objects. Okay, thank you for listening.